Hello, everyone. My name's Hyegang Kim, majoring in Creative Technology Management at Underwood International College of Yonsei University. The topic I'll be covering today is Chapter 1 of Head First Programming, which discusses the very basics of Python. Now, let's get started. To begin with, let's go over the tools that we'll be using today. When you start Python, you'll notice that there's no actual name, a file named Python. Instead, you get to use idle or Jupyter Notebook or any of those programs. What's the difference? Idle is an encoder. It's in a language that we humans can't understand. And therefore, our job is to create codes using these encoders. When you make a file with the encoder, they're saved as Py files. Python translate these files, which you can make with the encoder, into computer languages and enables us to order stuff to computers. To better understand the main topic that we're going to be dealing with today, I thought it would be better if I started off with explaining the data types and basic functions that are inside Python. In Python, the main data types are numbers, strings, boolean, lists, tuples, dictionary, and set. Because of the time being, we will only take a look through those that will be used today and the important ones. First goes numbers. Numbers can be divided into three categories: integers, floats, and complex numbers. Integers are real numbers without any value after the decimal point. As you can see, there are 1, 2, 0, -1, 10, 200, and etc. The reason I put four apples in it is because those are four whole apples, so there's nothing after the decimal point. On the contrary, floats do have something behind the decimal point, such as 1.0, 2.88, 3.14, 2.12. Notice how there's a 1.0? In Python, point 0 also counts as having value, so the whole number becomes a float. Floats are ones that do have something lower than the decimal point, so that's why I put orange, a split orange, and a quarter orange to express them. There's something behind the decimal point. And then complex numbers are numbers that have an I in it. And for Python, they use J in it. I'm sure you might have heard of complex numbers in math class. Those weird ones with -1 inside a root. Anyways, it's not that important. That's important in math class. You can see that the most used function in here is integer because, as you can see, only int is shortened out. The rest is float and complex in its whole form. Well, it is shortened out so we can quickly use it because we use it often. And numbers are important because other data types such as strings and tuples cannot go through a mathematical process such as addition, subtraction, and even comparing values through greater than or lower than. That's why you use numbers so much. Next up are strings. Strings are usually inside double or single quotes and can contain just about anything. It also does not function in any way that we can't understand because it's just human language and are used as a label or what we should print out for the users to read. Therefore, there is not much confusion in using strings, just that they always need to be in quotes. If not, you'll get the message where it says EOL missing letter or something like that, which will irritate you to death when you have a whole bunch of other problems to fix as well. Keep in mind that a single error in your codes usually result in not being able to do anything with your other codes. That's too bad, isn't it? And then there's Boolean. To make it seem simple is, well, it is simple. It's a true or false question. So the answer for Boolean can only be printed in true or false. There's one boolean that we will be using today. The rest or of the data types will not be used or won't be of that importance in today's topic, so I'll just skip those and move on to our main exercise. So today, we're going to make a guessing game. It's just really basic stuff. If the user guesses the correct number, it should say that it's correct. And if not, it should say that it isn't correct. Let's see how this should work. Now, this is our very first version of the game. If we start the game and guess the wrong number, it prints out it's wrong. If it's correct, obviously, it should print correct. Simple, isn't it? Let's take a closer look at its aspects. So, in the first line, you can see the print function. As you can guess, it literally prints what's in the bracket. And you can see those double quotes, those are strings, the one we discussed previously. Next, we can see the input function. If we use the input functions, whatever string you type in the quotation marks are printed out in the interactive shell, and a blank pops up where you can type in things. Oh, by the way, what's an interactive shell? You know, when you open up idle, there's two screens. One is this one, and another is this one. So this is where you type in the codes, and this is called the interactive shell, where you can see the results of your codes. Anyways, moving on. Oh, might have spoiled some. And up next is int function, which I've talked before. That stands for integer. If there is that int and bracket, whatever's inside the bracket, whether it's a string or float, if it's convertible, turns into an integer. So, like I said, 5 with the quotation mark is a string. However, 5 with the quotation mark covered with int becomes an integer. So it's changing the data type. Okay. Next is if. If statement is used in the same context as we talk. So it's simple. If guess is 5, proceed in that order. Else, follow the else statement. Simple, isn't it? Now is where it gets kind of tricky. Notice that there are 2 equals instead of 1, but everywhere else there's just a single equal sign. Let's see what's the difference between the two. So to make it seem simple, a single equal sign is used to assign a value to a variable. You're naming things. In this case, A is called Sam, and from now on, whenever I say A, it directs to Sam. So hello A means hello Sam. Next, double equal sign is used when it's comparing the two before and after. In this case, it is used to see if B has the value 3. This statement will therefore return a form of true is the same or false it isn't the same. And this is the data type boolean that I discussed before. Now let's look back to our game. You see, it says G is from now on the thing you input. Again, guess is G, the input value in integer form. Therefore, guess is the integer form of what you input after guess the number. So this line of code does the exact same function when it is converted like this. So I hope you all understood this part because it was the most confusing for me when I first started Python. G is input, the integer form of G is guess, and then that guess is being compared with 5, and if guess is 5, is print UN. If guess isn't 5, so else, print you lose. You see how different the equals are? What we want to do now is our game seems to be somewhat problematic though. It's just way too random. Why not give our players some hint in guessing, like these? Let's tell them whether their guess is too high or too low. We'll give a slight touch to the if and else statement to make this work. Let's look deeper into the if else statement. We'll go with the example of driving a car and seeing how much fuel we have to get downtown. Do you notice that these 4 lines of codes are indented? In Python, indentation is not used to make the code seem fancy. It is used to connect codes together. It's like making a path to follow. So if fuel is over 3, it follows the path of if, going like this. And else, it follows the path of else, like this. See? Indentation is what you always have to keep an eye on because it's one of the most common reasons you get an error like this when running the code. It's similar to the one I said before, EOL and this. These two are like the most common mistakes that new Python coders do. Now, let's apply this to our game so that there can be 3 types of responses: too high, too low, or you win. With this code, you can get all 3 types of responses. We use if first to if guess equals 5, printing you win. And if guess isn't 5, but if again guess is higher than 5, we print too high. Else, if it's lower than 5, print too low. So there are 3. You win, too high, too low. But if we run this code, we can see that we're only given 1 guess. And every time we're wrong, we have to rerun the code to make another guess. Wouldn't it be much better had we been able to continue guessing until we get it right? What we now have to use in this case is a loop. It should run over and over and over until we get it to a certain condition. In other words, until the condition is false. In this image, we can see that the answer will be set as no in the first place. And we see the loop. You see the loop? If the answer is no, we're going to make an input. Are we there? So we've discussed about input before. This means that it's gonna print out are we there in the interactive shell, and then you're going to have to type in something behind it. So when the answer is no, the first answer is obviously no. It goes through the loop and answer is input are we there. So answer is going to become what you input after are we there. If you input no, then it goes through the loop again. Is the answer no? Yes. No. What am I saying? The answer is no. So it goes around again and it prints out are we there? And you're going to have to answer it again. If you say no, it's going to go over and over and over. But if there's anything else than no, say just one, even if you say 1, it's going to print we're there. See? This is how the loop works. And we're going to use it. There are 2 loops in Python, while and for, but today we're going to use while loop. The green part is what we used to do until now. And we use the while loop to make it run over and over. Let's look at the new features that we had to add on in order to use the while loop. First is this part, guess equals 0. It sets guess as 0, but why do we need this line? It's because to make the while loop function, we use guess is not equal to 5. This part over here, guess is not equal to 5. In order to do something with guess, you need to know what guess means. As you can see, guess is not 5. So it's similar to the one we did before. Answer is no. This part is the same as guess equals 0. It's a given guess. So we make the loop go around the first loop. So while guess isn't 5, it loops around and around. And the guess will be different later on because guess is int g from now on in the green part. And then it goes back up. And while guess isn't 5, it continues. However, if guess equals 5 and whatever's after a while becomes false, it breaks and then it prints game over. Now, as you can see, you may have noticed, but equals and exclamation mark together, it means not equal to. There's like no other way to express it with a keyboard, and that's just how Python made it. Now the program won't rerun and it'll function continuously. But what did we want to do in the first place? Do you remember? We didn't want to guess 5. We wanted to create a game that makes us do random guesses. But in this case, the answer is fixed to 5. How can we make it change the answer every time we run the program? We'll be using a new tool that you're going to have to use every day, the import. What it does is that it brings another module or file and uses the functions that are available in that file. It's like borrowing functions. Why do we use this? We can't code every single time the tools we have to use. Some are just provided so that everybody can use it. It's just much more simple. For example, there are a whole variety of modules which can be used to create pop-up screens or convert text into sound files, but you're not going to type in how to convert text into sound files every time you make a code. That's why you just import it. In this case, we'll be using the random model, which is used to generate random numbers. From random, we'll import random integer, which is a function, randint. And the secret number will be called secret from now on and be in range of 1 to 10. Oh, by the way, let's take a brief look about the differences between normal range and randint's range. In normal Python range, it sets the number from the first number and closes before the last number, meaning it does not include the last number in the range. However, for randint, it includes the last number, so it's important not to be confused between the two. If its range in this case 1, 10 in randint, it becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for randint. However, for just Python range, well, it's not used in this context, but you're gonna face it someday. If it's range 1, 10 in regular Python, not random, it'll become 1, 2, 3, 4, 5, 6, 7, 8, and 9, not 10. That's the difference between the two. And try not to confuse the two because it's really confusing later on. Anyways, let's get back to work. So if we replace the files that we used until now with secret, it will turn out like this. Guess while guess is not secret, G is input guess the number, guess is the integer form of G. If guess is the same value as secret, print you win. So secret is a random number between 1 and 10, so the computer automatically chooses which number it is. Print you win if it's correct. If it's higher than secret, print too high, else print too low. And then when the while loop breaks, print game over. And on the right is interactive mode, which I tried out using this Py file. So it begins with welcome. I guess 2, it was too low. And we ran the program automatically with the while loop. Guess 3, it got too low. 7, too low. 9, too low. And then I got the number 10. And then game over. This is the end of our guessing game for today. So we've learned what is Python, the basics of Python, and how to use some of the very easiest commands of Python, such as import and loops. But these are the most important, I think. I hope this video could help you out in getting into Python. Thank you very much for watching.